So today we are going to understand what are the different ways of propagation of radio waves. Okay. Number one, there is a child, basically a toddler, doesn't know how to walk. There's a child in your house and this is you who wants to play with the ball with him. How will you pass this ball? You'll just push it like this, right? To let this ball go to the smaller child. Second way, if this baby grows up, he's no longer a toddler, he's like able to walk now. Now you want to play ball with him. Once he grows up, you will throw this ball like this and this guy will receive it like this. Right? This is how you are going to play when this baby grows up. Similarly, there are two ways in which you can send the waves also. Number one is the ground waves. The other waves are sky waves. Ground waves are basically one antenna is here, some other antenna is here. Whatever is the means of propagation, it will go like this from one place of ground to the other place of ground, from one antenna to the other. We are not using sky, we are not using the space, right? What does sky wave mean? Sky waves are the one, if this is earth, we are using the sky above us. There is one transmitter. We will abbreviate transmitter as TX and receiver as RX. Transmitter and receiver. I will send this wave in the sky. It will reach ionization layer, which is ionosphere. Ionosphere basically will have ions in it. These ions will reflect back this wave. There will be a total internal refraction. Right? This is how you will get these waves. Okay. So number one is you can send it via the ground. Number two is you send it up in the air. There will be some particles. The wave will hit those particles and come back and you will receive them on the receiver. Correct? Now let us see. So the one which we are doing on ground, are we using ionosphere or sky in that? No. What we are doing, we are simply sending the wave from one place to the other, not using the ionosphere. So that type of propagation is known as non-ionospheric propagation. What are we doing? We are using the surface waves or the ground waves. The one in which we are using ionosphere, that is known as the ionospheric propagation path, the ionospheric method of transmitting and receiving the signals. Okay. We will divide known as ionospheric and ionospheric. Number one is the ground wave, the other one is the sky wave. Ground wave or the surface wave. First, we will see the non-ionospheric propagation. So, number one is the surface wave. The frequency used in surface waves are the lower frequencies. The lower frequencies or VHF frequencies. Very low frequency till low frequency, medium frequencies, these are used in the surface waves. What are the frequency we will be using for surface waves? It is 20 kilohertz to 50 megahertz. For the ground propagation, to send the wave from one place to the other, what kind of frequency we are using? 20 kilohertz to 50 megahertz. Correct? Now, 20 kilohertz lies in which place? VLF, LF, MF, HF, VHF, UHF. 300 to 3000 kilohertz. HF is from 3 to 30 megahertz. 30 to 300 megahertz. Where does this 20 kilohertz lie? In which frequency band? This 20 kilohertz will lie in the VLF
What
range,
frequency? 20, okay, okay. Really.
right?
Yes, sir.
So we are starting to use our ground waves starting from VLF frequency and we are going till 50 megahertz. 50 megahertz means somewhere between this 30 to 300 megahertz.
Yes.
So we are using these frequencies between VLF and VHF, upper VLF and lower VHF.
Yes. Yes.
This is the frequency we are going to use for the surface waves. Okay? And what is happening in this way, in this method of propagation? This radio wave is always in contact with the surface of Earth. And we have seen whenever any wave comes in contact with the surface of Earth, what happens? It attenuates. Basically, it loses the signal. Correct? Now, there is a property known as diffraction. Do you remember from your lower classes what was diffraction? Diffraction basically means the bending of light wave across any corner. Remember, there was a double slit experiment, Young's double slit experiment. In that, he had told about the wave fronts. But in the diffraction experiment, they had told that the light waves are bending around this hole. So whenever there is any obstacle, the light waves, they tend to bend around the corners. Correct? Now, in the case of Earth, where are these waves getting hit by? Like, where are they touching? They are touching the Earth. Correct? So do you think that instead of going into this path, it should have gone in this path? It should have gone like this. But because of the property of diffraction, that means they bend around the surface of Earth. That's why they are taking the curvature of Earth and flowing along the curvature. Right? This is what diffraction means. Now we told about attenuation as well. That there are surface waves. The frequency band which is being used is 20 kilohertz to 50 megahertz, which is from upper VLF to the lower VHF. One property is that there will be diffraction. That's why instead of going directly like this away from the surface, they are being moving along the surface of Earth from one point to the other. Second thing, we had seen yesterday that the waves attenuate when they go from one point to the other. Correct?
Yes.
So, what do you think if I increase the frequency? Like, if I'm using number one case, if I'm using 20 kilohertz, And number two, I'm using 50 megahertz. Let's assume. What will happen if I use 20 kilohertz and what will happen if I use 50 megahertz? Which wave do you think will attenuate more? This is
50,
point A, this is point B. Yes? Which one?
50, 50
Perfect.
megahertz.
Yes, you said it correct. 50 megahertz will be attenuated more. Because when you increase the frequency, the attenuation is also increased. If you reduce the frequency, there will be less attenuation. For the ground waves only, we are only talking about the non-ionospheric propagation. This case is opposite when we study about the sky waves. In that, more the frequency, less the attenuation. So right now we are talking about ground waves and you said it correct that if you increase the frequency, the attenuation will be more. Correct? So when we are using the surface waves, we will try to use the lesser frequencies only. Correct? Okay. Now, let us write a point here only. That more the frequency, more attenuation. The frequency, more attenuation. Okay. Next type of waves under the surface wave propagation. The non-ionospheric propagation is the direct wave. Direct wave means they are also known as the line of sight waves, LOS. Line of sight. What do we understand by a line of sight? That means we can see the wave with the eyes. Like the direction in which we are looking, we can send the waves. Basically, if there is a transmitter like this, if I send a wave like this aircraft receives the signal. This is known as a line of sight wave. So, direct wave is basically line of sight wave. That means the waves are received directly on the line of sight path or the direct path. There is no obstacle in between, no earth, nothing. So, till now we have seen two types of waves. One was the surface wave, which was moving like this, going from one point to the other. Number one was the surface wave. If you are sending directly, then that wave will be known as the direct wave or the line of sight wave. Correct? Now, let's look at the third type of wave, ground reflected wave. Ground reflected wave is like, suppose this is a transmitter, there is an antenna here, and there is a sea over here.
Ma'am, RX is the receiver end, ma'am.
Yes, Rx is the receiver end. Px is transmitter, Rx is receiver. Okay. The third type of wave we are going to study is the ground reflected wave. As the name suggests, there will be a wave, it will hit somewhere on the ground, reflect back, and then the other person will be able to receive your signal. That means if we assume this is the transmitter and you send a wave, it hits this surface of sea or the ocean and it goes back, and there is some aircraft here, then this aircraft receives this wave. This type of wave propagation is known as the ground wave. Sorry, ground reflected wave. Okay.
Yes.
Now let's look at the frequency bands. Till now we have seen that lower frequencies, medium frequencies, we are using the ground waves. For high frequency communication, we are using the sky waves, which uses ionosphere, that is known as the ionospheric propagation. And space waves are the one which use VHF and above. Let us classify them. See, in the start of class we had studied that in non-ionospheric propagation, we will use frequency 20 kilohertz to 50 megahertz, correct?
Yes.
VHF starts from 30 megahertz to 300 megahertz. Do you agree?
Yes.
So we had said that from VLF to VHF, upper side of VLF, because 20 kilohertz is near to the upper end,
No,
30 kilohertz. And lower end of VHF is nearly 50 megahertz, which is on the lower end of VHF frequency band, correct? This is what we had said, that this band covers upper VLF till the lower VHF, correct? But in between, we have a frequency band known as the HF band. This one, correct? This band is used for ionospheric propagation. This we will see later. Just to explain that table I am telling, HF band uses ionospheric propagation. This band and this band. Let me cover it with a different color. This band and this band. This band is going to use the surface waves or the space waves, basically non-ionospheric propagation. Correct? So if someone asks you if you want to use ionospheric propagation path, what frequency will you use? Simple answer should be HF frequency. If someone asks you if you want to use non-ionospheric propagation, what path will you choose? You will simply say VLF to MF and VHF. We can reach till VHF. Correct? Now, next part is space wave. Space wave is nothing but the combination of direct waves and ground reflected waves. They as a together are called space waves, commonly known as the space wave. Okay? And space waves are using the VHF frequencies. So these both bands are part of non-ionospheric propagation, and this is a part of ionospheric propagation. Just now we have seen that. Okay. Now let's revise all what we have studied in one diagram. This is our ground. This is our space. Number one. What was the first wave we had studied about?
Professor.
Surface waves. There was a transmitter. There was a receiver. And it was using LF2, VLF2 MF band. Correct? Transmission was like this. This was known as the surface wave. Correct? Number two, we studied about the direct wave. Direct wave means there was a receiver here. Receiver is basically any aircraft or any other station on the ground. If this antenna is releasing a signal, it might be reaching here also and it might be reaching here also. So both of them act as a receiver. Okay. If this transmitter sends a wave and it directly is received by any aircraft, this is known as a direct wave, right?
Yes.
Number three, we had seen there was a wave, it went on the surface of Earth, reflected back and reached the receiver. This number three wave was known as ground reflected wave,
Reflected.
correct? And this number 2 plus number 3, that means the direct wave plus ground reflected wave. It is known as, the terms both combined is known as the space waves. And space waves have frequency in the VHF band. So this is what we have studied so far. Done?
Yes.
Okay. This was the non-ionospheric propagation methods. That means you are just using one transmitter and the receiver in the different ways, but you are not using any space. Like in the ionization layer, you are not using in this one. That's why it is known as the non-ionization propagation. Can you tell me all the four ways you can transmit these waves? Number one is
Surface wave.
surface waves using a frequency band of,
20,000 20 kilohertz to the megahertz.
yes.
Yes. This which one is direct wave? No?
Yes.
Di- Direct wave is directly transfers the waves to the aircraft without any
Without any obstacle,
without
basically. Going
yeah
from
without
one
any
point to the other in a line of sight direction.
I know sir. Yes.
Like this, like this. These are the line of sight waves.
Yes. Yes.
Then number three.
And number three is ground reflected wave. No?
Yes.
The transmitter first reflects on the ground and it reflects
Yes.
back to the aircraft which is in the air. And the
Yes.
fourth one is a space wave, which is combined of both, which is direct
Yes.
wave plus
Ground
surface
wave.
reflected.
Ground reflected wave.
Ground reflected.
Ground reflected wave. If we just talk about the surface waves, in questions, sometimes it is said that they use a frequency band of upper LF and lower MF. These space waves, since we have seen in this diagram, see, in this table we had seen that the frequency band used by the ground waves only is the LF and MF band, and in total, the non-ionospheric propagation uses LF till VHF. Only if someone asks about ground waves, you will say the frequency band is upper LF, lower MF. If someone asks you about the total non ionization propagation, you will tell upper VLF to lower VHF. Got it? Just asking about the ground waves, LF and MF. Okay. Now we will see the ionospheric propagation. In ionospheric propagation, we are going to use ionosphere. You must have studied in meteorology about ionosphere. What do you understand about ionosphere and what all happens there? Do you remember anything from met class?
Ionization.
Yes, ionization happens. Ionization. And what is ionization? In
Then the
ionosphere,
surface.
basically there are different molecules, correct? Let us make one ionosphere like this. Assuming this is ionosphere, there are molecules existing nicely, not disturbing anyone, not doing anything, just existing. There is a mighty sun over here, right? Now, this sun keeps sending its rays to earth. Agreed?
Yes.
These rays, when they hit these molecules break into ions, positive and negative. Correct? So, now these molecules, when they are hit by the sun rays, they break down into different types of ions, positive and negative ions. Correct? Now, do you understand what is ionization? It is basically the process of breaking down of molecules into ions. Do we need ions or not in ionospheric propagation? Yes, we do. What basically happens in layman's language is this is our earth. We have used a transmitter. We are going to send these signals. These signals will be hit by any of these ions and they will reflect that wave back. And then you will be able to receive it either on the aircraft or if you are using a receiver as any antenna, then you will be able to receive it on the different part of antenna. Correct?
Yes.
So what are sky waves? These are the waves which are reflected from ionosphere. They are using HF frequency, and these waves are reflected from the ionosphere. Now, as we have seen that it uses HF radio, HF frequency, high frequency. Do you think it is used for short distance communication, or you can use it for a long distance communication?
Frequency.
Yes, it is a high frequency. So can we use it for short distance communications, or we will use it for long distance communication?
Um,
Long distance communication. Good. Since we are transmitting the wave from one place on the earth, going back to the ionosphere, hitting back and coming back to earth, it covers almost 1000s to 1800s of nautical miles. Whereas if you were using ground waves, you could go hardly 150 to 200 nautical miles. 150 to 200 nautical miles you would have covered if you were using ground waves, max to max. If you are using the high frequency or the sky waves, do you see how much has the range increased? Almost 8 to 9 times. That's why we say that we can use it for long range communication, right? Now, let us understand the different layers in ionosphere. When you have studied in meteorology, you must have studied only ionosphere, as it is a layer where ions occur. There are ions in this. But when we study in navigation, we will even divide this ionosphere into three different layers. What are the three